Good evening, all. I am continuing with my last topic through the video of Laplace transform. The rule name is division by t rule. In the last lecture, we have completed the multiplication by t rule. Now, the property is if any function is divided by t, then how to find the Laplace. So, the formula is if it is multiplication by t, then we will follow the derivative rule. But if it is division by t, then what to do? We will find the Laplace of the function first, then do the integration from s to infinity with respect to s. So first we will find the Laplace, then we will do the integration from s to infinity. Here are some examples I will solve step by step. So same way we will solve as we are doing in the classroom. So all can observe here it is multiplication by t. If it is multiplication by t, then we will follow the integration. Remember, the limit is very much important. Integration limit is s to infinity. Function is sin 80, so we will find the Laplace of sin 80 ds. Why ds? Because the Laplace of sin 80 will come in the terms of s. So it is from s to infinity. Laplace of sin 80, everybody knows it is a upon s square plus a square ds. Now a is constant, so it is s to infinity 1 upon s square plus a square ds. We know the integration of 1 upon s square is tan inverse s by a s to infinity. So the a same, so it will be tan inverse infinity minus tan inverse s by a. So a same, tan inverse infinity we know it is pi by 2 minus tan inverse s by a. So the final answer is a into cot inverse s by a, because the two formulas we know, integration of 1 upon x square plus a square dx is tan inverse x by a, and second is tan inverse x plus cot inverse x is pi by 2. So it is pi by 2 minus tan inverse, so it will be pi by 2 minus tan inverse will be cot inverse. So final answer is cot inverse s by a. So this is the first problem. Now see again in the second problem it is divided by t. So we will follow the same rule, integration from s to infinity. We will find the Laplace of this. Laplace of 1 minus e raised to 2t with respect to s we will solve. So integration s to infinity. What is Laplace of 1? Everybody knows it is 1 upon s. If it is positive 2, we are writing s minus 2 as we discussed in the class. So integration of 1 upon s is log s. Same way integration of 1 upon s minus 2 will be log s minus 2. Limits from s to infinity. So we know if it is subtraction, then we are doing division in logarithmic. So s to infinity. Now when we apply the limit to this s upon s minus 2, so I am solving this separately. Limit s tends to infinity s upon s minus 2. So it is limit s tends to infinity, s common in the denominator, so we will get 1 minus 2 by s. So this get cancelled. So 1 upon 1 minus 1 up 2 upon infinity will be 0. So the limit is coming as 1. So when we will apply infinity to this term, so answer is coming 1. So it is log 1 minus replace s by s itself. So same we will get. We know the log 1 value is 0 minus log s minus upon s minus 2. So this minus will go in power. So minus 1. So final answer will do the reciprocal because power is minus 1, s minus 2 upon s. This is our second problem. I hope this is clear. Let us do the third one now. Laplace of cos at minus cos bt divide by t. Again divide by t, so same rule, s to infinity. We will find the Laplace of cos at minus cos bt ds. We know the formula of cos at, so it is s upon s square plus a square minus s upon s square plus b square ds. There is one rule of integration. We can see the denominator is s square plus a square. So the derivative of this term would be 2s plus 0. So we require 2 in the numerator. So we require 2s in numerator. So I am dividing and multiply here both the sides by 2. So I have multiplied both the terms by 2. So basically we will divide, then we will get the same answer. So multiply and divide by 2. So the formula is integration function in the denominator and its derivative in the numerator. So the formula is log mod of that function, this formula. So here function in the denominator, its derivative in the numerator. So the answer will be 1 by 2 log of, what is denominator here, s square plus a square. So log of s square plus a square minus, for second also same, but denominator is log of s square plus b square. Limits would be same, s to infinity. So if same process as we did in the last problem, so it is log of x square plus a square upon s square plus b square. Subtraction will convert into the division. So here again we will apply limit s tends to infinity first, s square plus a square, s square plus b square, taking s square common. So it will be 1 plus a square upon s square, 1 plus b square upon s square. So this get cancelled. So it is again 1 plus 0, 1 plus 0. So it is 1. So limit of infinity we are getting as 1. So half times log 1 minus log same s square plus a square, s square plus b square. So the final log 1 is 0. So answer is minus 1 by 2 log s square plus a square, s square plus b square. You can stop here also, otherwise take minus half in the power, do the reciprocal, take root, otherwise leave as it is, no problem. So fourth problem, again division by t. So integration s to infinity Laplace of 1 minus cos t ds. Now you know the method, so I am doing fast. S to infinity Laplace of 1 is 1 by s. It is 1 s upon s square plus 1 ds. So integration of, here integration of 1 by s is easy to find, but here we have to divide and multiply by 2 to get the form of formula, function in the denominator, its derivative in the numerator. So integration of this would be log s, here 1 by 2 same, integration of this would be log of s square plus 1. So here it is log s minus log, half will become in power s square plus 1 half. So it is log s upon s square plus 1 half means root s square plus 1. Limit same, s to infinity. Again limit s tends to infinity, s upon root s square plus 1. So limit s tends to infinity, taking s common, so it s square common. So root s square will be s, in the inside it will remain like this. So again we will get the same, 1 upon 1 plus 0, so it is 1. Basically the limit is same for infinity in all examples. So upper limit is log 1 minus lower limit is same because it is s. So log 1 is 0, so it is minus log of s upon s square plus 1. This is the example of assignment, so this is most important. Let us solve this last problem. S to infinity Laplace of t minus sine hyperbolic phi t ds. What is Laplace of t? It is 1 factorial upon s square minus hyperbolic, only sign will change, phi upon s square minus 25 integration s to infinity dsm. So integration of 1 upon s square will be minus 1 upon s, phi same. Integration of s square minus a square is 1 upon 2a. Let me write the formula first. Integration of 1 upon x square minus a square. So it is 1 upon 2 log x minus a upon x plus a. This is the formula. So it is in replace a x by s and a by phi. So we will get here phi same 1 upon 2 log s minus phi upon s plus phi. This is the formula, s to infinity. So it is basically minus 1 upon s minus phi over 2 log s minus phi upon s plus phi, limits from s to infinity. When you are applying infinity here, so 1 upon infinity will be 0 and log 1 is also 0. So applying infinity will give us 0, and same for s. So the final multiplication answer is 1 upon s minus minus plus phi by 2 log s minus phi upon s plus phi. Here the last problem is actually this one, shifting with division by t. We know if the shifting is there, we will applying at the end. So first we will do what? Integration s to infinity Laplace of sine 2t ds. Same procedure according to last example. At the end we will replace s by s plus 1 because it is negative 1. So replace s by s plus 1. This procedure. So first one step will be increased here, only replacement of s by s plus 1 remaining same. So sine 2t we know it is 2 upon s square plus 4 ds, easy example. So 2 outside, 1 upon x square plus a square formula is again tan inverse s by a is 2, s to infinity, replace s by s plus 1. So when you are applying infinity, you will get tan inverse infinity minus tan inverse s by 2. Replacement we will do at the end. So same procedure, tan inverse infinity is pi by 2 minus tan inverse s. So 2 times pi by 2 minus tan inverse becomes cot inverse s. So it is 2 times cot inverse s plus 1. So it is shifting with division by t. Now one exam I am giving as a homework. This is your task, students. Sine cube t by t. All the best guys. Give your 100%. Remember that I want O in mathematics. So mid-sem is most important. All the best.